Welcome to springlib.
So the total energy E of the particle of mass m is given by E is equals to half mv squared plus u. And the object is acted upon by the conservative force. And they're saying use conservation of energy, which is dE by dt equals to 0 to predict Newton's second law, which means we need to arrive at an equation F is equals to ma using this. So note that the energy is constant, so the derivative of energy with respect to anything is going to be 0. So what we're going to do is that we are going to find the derivative of this with respect to x first. So dE by dx is equals to half m2v dv by dx plus du by dx. Now this should be equal to 0 because energy is constant, so derivative of that with respect to x is 0. This 2 and 2 cancels, and I'll just replace velocity with dx by dt, this velocity here. So this is m dx by dt times dv by dx plus du by dx should be equals to 0. Now we also know that dv by dt is equals to a. So on the left hand side we have got ma is equals to minus du by dx. So if you can only prove that this term is equal to force, the problem will be solved. So we'll do that on the next page. So especially for one-dimensional case, when the force or the conservative force actually can be written as a function of x. Like for example, the potential energy is the Hooke's law, the force is equals to minus kx. So if you stretch a spring in one dimension and it is a conservative force, it can be written as a function of x according to this equation. This is just an example of a conservative force. So if this is the case, then in this case, the potential energy, which is u of x, can be expressed as the integral of f of x dx plus c. This negative sign is just to represent that the force is opposite to the direction of displacement. Now if we derive this equation with respect to x, du by dx is equals to minus d by dx integral f of x, and the derivative of that is 0 because it's a constant. So we are just left over with negative f of x. If you solve this equation, we get f of x is minus du by dx. So therefore, we can combine the equations on the previous page to show that f of x is equals to ma.